Hello guys, welcome to my channel. This is the 42nd tutorial in this course, and in this tutorial we are going to make a program that's going to generate prime numbers between 2 to 100. We're going to use nested loops in this program, so if you guys don't know what nested loops are, if you want to know more about nested loops, then you can watch the tutorial on nested loops in this course. I guess it's the 39th tutorial, so you can watch that and you would have a clear idea of how to use nested loops. And even if you haven't seen that tutorial, you can still watch this tutorial, and I'm sure you'll be able to understand, because nested loops are really simple. They're just loops within loops, and the syntax is pretty simple. So you can continue watching this tutorial and maybe watch that one later on. So as you can see, using code blocks, I've saved a file. I've given it the name prime. It has the extension .c. On line 1 in this file I have my header file. On line 2 I have the main function. On lines 3 and 4 I have my curly braces. Between the braces I'm going to put in the code for the program. Now, what is a prime number? A prime number is a number that is divisible by itself and 1, and it does not have any factor between itself and 1. And what I mean by that is 7 is a prime number, right? Because 7 is divisible by itself and 1, and it's not divisible by any number between 1 and itself, like 2, 3, 4, 5, 6. None of these numbers would divide 7, right? And 11 is a prime number, and 13 is a prime number, and so on and so forth. All the numbers that are divisible by just themselves and 1 are prime numbers, and we're going to make a program to find such numbers between 2 and 100. And we're going to use two loops. Both are going to be for loops, and the outer loop is going to run through the numbers 2 to 100, and the inner loop is going to check whether each number between 2 to 100 is a prime number or not, right? So for the two loops I'll need two control variables, and I'm going to call my control variables I and j, and both are going to be integers. So to declare them, I'll have to type in int space I comma j, and I'll put a semicolon to terminate this statement. On the next line I'm going to start my outer for loop statement, and I'll have to give I initial value 2, and I'll have to have a test condition I less than equal to 100, right? Because we're going to loop through 2 to 100, so that's why the initial value of I has to be 2 and the final value of I has to be 100. We're going to increment I in steps of 1. And in the body of this for loop we're going to have another loop, and this one's going to use j as the control variable. And what this loop is going to do is we're going to use j to check whether I is divisible by j or not, and we're not going to use just one value of j. We're going to use all values of j between 2 and I, right? So we're going to check whether I has any factors between the number 2 and itself. So understandably the initial value of j is going to be 2, and we're going to loop through j from 2 to I, right? And of course we're going to increment j in steps of 1 as well. And in the body of this loop we are going to use if to check whether I percentage j equals 0 or not. And what we are doing through this if statement is we are checking whether I, when divided by j, leaves a remainder of 0 or not. And if that is the case, then j perfectly divides I. If that's not the case, then it doesn't, right? And if this is the case, then we're going to break, right? Because what this means is we found a factor for I, and we don't have to check for any more values of j, and we can simply break out of the inner for loop. And remember, this break statement is going to just get us out of the inner for loop. It's not going to get us out of the outer for loop, right? And outside the body of the inner for loop, we're going to have another if statement, which is going to check if the value of I is equal to j or not. And the reason why we're doing this is because we're looping for the control variable j from 2 to I, right? So this if statement could return a true value even if j is equal to I, right? Because the final value of j can be I. And if that is the case, then it means that we haven't been able to find a factor between the number 2 to the number I apart from the number I itself. And what that means is that I is a prime number, right? So I hope this is not getting too complicated. really just slow it down and try to understand, copy the code, write it down on a piece of paper, or you can pause the video after the program is complete. Just copy the code in your code blocks or other IDEs if you're using something else, and you can execute the program, see the output, and I'm sure you'll be able to understand. So if I is a prime number, then we have to display it on screen. So we're going to do that by typing %d, the format specified to print the value of I is a prime number. And of course, we're going to put in the new line escape sequence at the end, and we don't have to give a space after the full stop and comma I, right? So this is going to print the value of I on screen, put a semicolon to terminate this statement, and with this, our program is ready. So when I click on build and run, I see that this is the output I get. 2 is a prime number, 3 is a prime number, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41. So all these numbers are prime numbers, and you can check for yourself. As I said, 7 and 11 are prime numbers. We spoke about them, and all of these numbers are prime numbers, in fact, right? So the logic of this program should not be too difficult to understand, and the final prime number that you have between 2 and 100 is 97, and of course 98 and 99 are not prime numbers, and 100 is divisible by 10, right? So that's it for now. In the next tutorial, we are going to talk about something interesting again. Thank you so much for watching this tutorial, and please subscribe to my channel in case you haven't already, and I'll see you soon.